So in the previous video, I talked about the internet. I talked about what is a protocol, what are the different types of protocols that exist on the internet. And now we are going to talk about the network edge. Again, if you look at the internet structure, you have the network edge, which basically comprises of clients and servers. We have the access networks. It could be a mobile network, a home network, or enterprise network. And then we have the core of the network, which is basically the network of routers of ISPs, which are connected to each other. So the question is that how do we connect the end devices to the edge routers of these access networks? So it really depends on in which access network you are. So for example, if you are in the home network, you might be connected to the edge router through a wireless link or maybe through the Ethernet cable. If you are in a mobile network, then you are connected to the BTS or the base transceiver station of the company wirelessly, and then BTS is connected to the edge router. If you are in an enterprise network, again, you might be connected through a wireless LAN, or you might be connected through the Ethernet cable to one of the switches, and that switch is then connected to the edge router. Now let's take a look at the residential access networks. And now there are two uh, common types of broadband residential access networks. One is called the cable-based access network that you see it here, and the other one is called the DSL, or digital subscriber line, which we are going to discuss shortly. But there is also a third type, which is becoming more popular nowadays, that is called fiber to home access network. And those of you who are living in the United States, they might be familiar with Verizon is providing you with fiber to home, which of course has a higher transmission rate as compared to the DSL or the cable-based internet access. Now, talking about the cable internet access, it makes use of the cable television company's existing cable infrastructure. And a home typically obtains the cable internet access from the same company that provides you with the cable television. You should also know that each neighborhood junction of this network typically supports between 500 to 5,000 homes. And cable internet access requires a special modem called cable modem, as you can see it here in this picture. Uh, this cable modem is connected to the cable head end of the company's central office, and then this link is shared between multiple homes. Now, there are different types of techniques that are used to separate various types of traffic, or if multiple homes are sharing, then their traffic would also be separated by using, you know, techniques like FDM, for example, that you see it here. FDM is basically frequency division multiplexing, which divides the bandwidth or the channel into different frequency bands. So here you can see that it's just an example that the link or this channel physical link is divided into 9 frequency channels, six of which is carrying video data, and then 7 and 8 is carrying internet data, and then channel number 9 is carrying control information. Now, you can see here that it is also mentioned as HFC, which is hybrid fiber coaxial. Basically, between home and the cable head, usually the coaxial cable is used, which carries your TV related data and the internet related data on different frequencies. And then the cable head end is connected to the ISP through the fiber cable. That's why it is called HFC, or hybrid fiber coaxial cable. You can also see that the cable modem divides the network into 2 channels, a downstream channel and an upstream channel. The transmission rate of downstream is between 40 megabits per second to 1.2 gigabits per second, whereas the transmission rate for upstream is usually between 30 to 100 megabits per second. One of the important characteristics of cable internet access is that every packet that is sent by the head end travels downstream on every link to every home. And then every packet which is sent by the home travels upstream to the head end. Now, if several users are downloading a video file on the downstream channel, the actual rate at which the users receive its video file will be significantly lower than the total cable downstream rate. And of course, the reason is because it is being shared. The bandwidth is being shared between multiple residences. On the other hand, if there are only few users that are web surfing, then each of the user may be able to receive the web pages at the full cable downstream rate, and that is because there could be a rare situation in which, everyone is, you know, browsing the same exact web page. The second type of the residential access network is DSL, or digital subscriber line. Now, residents will typically obtain a DSL internet access from the same local telephone company that provides its wired local phone access. And therefore, when DSL is used, a customer's telco company is also its ISP. The residential telephone line in this DSL will carry both the data and the traditional telephone signals simultaneously, but they are, of course, encoded at different frequencies. So here you can see again, similar to the cable-based internet access, you have a DSL modem. In the cable-based, you had a cable modem. Then you have a splitter, which will separate the telephone data from the internet data, and then it is connected to the central office. And from the central office, again, it is going to multiplex the data towards the ISP network, and then the calling data towards the telephone network. Now, the DSL has lower transmission rate as compared to the cable-based access network. So here you can see that the downstream transmission rate is 25 to 52 megabits per second, whereas the upstream rate is between 3.5 to 16 megabits per second. So this is how the home network usually looks like inside the home. So you have a cable modem or a DSL modem here, which is connected to a router. This router is connected to, again, a wireless access point. Now, it is possible that all these three might come in the single box. It is also possible that they might come in two boxes. It really depends. Let's talk about the wireless access network. So there are two types of wireless access networks. One is wireless local area network. Typically, the range of wireless local area network is in, approximately 100 feet, or nowadays it could be a little bit more. And then there are different wireless local area network standards like 802.11b, 802.11g, N, I, F. So the difference between these standards, you can, look it up on the internet, but generally speaking, the difference in these various standards of 802.11 or wireless LAN is the transmission rate. The difference could be in the quality of service. The difference could be in the security of these standards. And then we have wide area cellular access networks. Again, we call it wide area because the coverage area of wireless WAN is much more as compared to the wireless LAN, and it's usually in tens of kilometers. The data rate in the cellular access network could be, tens of megabits per second. You're very much familiar with the 4G, 5G, LTE, and so on. The third type of access network is enterprise access network. Enterprise access network basically means the company's network. Now, the company's network, you might be connected, like I mentioned, through a wireless local area network, wireless LAN, I mean to say, or you could be directly connected to the switch through the Ethernet, which is then connected to the edge router. And then this edge router of the institution is connected to the ISPs. So let's have a look at when a host sends packets or data towards the internet. Um, so there are usually delays when a host is sending some data. So uh, normally the delay we measure it in terms of the length of the packet, which is usually in the bits, divided by the transmission rate of the link. So the packet transmission delay in our case will be L by R. L is the number of bits, uh, the length of the packet, and R is the transmission rate. The transmission rate is also known as the link capacity. It is also known as the bandwidth. However, there is a misconception that usually students think that the transmission rate means like how long it will take the the packets to be transmitted over the network. Well, that's not the transmission rate. The transmission rate means how long will it take to push all the bits of a packet into the link. And that's basically exactly uh, the transmission rate. Sorry, the time that it will take. You can call it transmission delay as well. Talking about the physical media, so eventually on the physical medium, the bits are going to be propagated in the form of signals, whether they're wireless signals or electromagnetic signals. There are different types of physical transmission mediums as well. The one that you see here is twisted pair cable. So twisted pair cables, they are, you know, different types of twisted pair cables. It could be a Cat5, which has 100 megabits per second, 1 gigabits per second as well. Cat6 has 10 gigabits per second, and now Cat7 and Cat8 are also out there. So within twisted pair also you will see UTP cables and STP cables. UTP are unshielded twisted pair cables and STP are shielded twisted pair cables. The difference is that one of them unshielded will have more interference and data loss as compared to the shielded twisted pair cables. Um, and then there are other cables as well, like coaxial, which we discussed is normally used in the cable-based access networks. So the coaxial cables, they are again copper wires, just like the twisted pair cables, which are also copper wires. However, the difference is between between these cables is how they're constructed. So coaxial cable, you can see it also has two copper wires, but one of them that you see here um, is covered with an insulation, separated with an insulation, and then the second copper wire is like a mesh around this insulation. And then this is the protective cover of this cable. Um, so multiple frequency channels, like we discussed, are there on this cable by using FDM. And the data rate or the transmission rate is usually hundreds of megabits per second per channel. Then we have the third type of physical media, which is fiber optic cable, which of course has a higher transmission rate as compared to the previous two. It can go up to hundreds of gigabits per second. And the reason is because in fiber optic, data is transmitted in the form of light. Another advantage of using fiber optic, apart from the higher transmission rate, is the low error rate. And because the data travels in the form of light, so there is no electromagnetic interference to the fiber optic. We talked about the wireless a little bit, but um, some of the other facts about the wireless communication or wireless channel or wireless media is that it's broadcast in nature, which means that the packets will propagate or will be broadcasted, and anyone with the receiver will be able to receive those signals or the data. There are security issues because of the broadcast nature of the wireless, but we will discuss it later. So wireless communication is mostly half duplex, which means that once the sender is sending the data, he cannot receive the data. And if he's receiving the data, he cannot send the data. Wireless, communication also suffers from interference, electromagnetic interference, obstruction by the objects which limits its coverage area. So we categorize them into wireless LAN, which we discussed, goes up to tens of meters. Wide area networks, which have more coverage as compared to the wireless LAN. And then we have wireless personal area network or PANs, which have shorter distance as compared to the wireless LANs. We have terrestrial microwaves as well, and satellites. In satellites, because of the distance, there is significant delay. Usually, but approximately 270 millisecond end-to-end delay is there in the satellites. All right, so the next topic that we are going to discuss is the network core